Welcome back, everybody. I told you this wasn't the end of IPv4. Now you know the basics. You seen this right at the very beginning where I gave you the key to do everything. And what was that key? That's right. It was a subnet mask. And you see, I wasn't lying. They not always give you a CIDR notation. They give you a dotted decimal number, our new terminology. Okay? What is the broadcast address of the network 172.18.43.128? All right? Whatever. I'm working in my last octet. Why? Because that's where they're all partially on, partially off. How many bits? Let's do it in our heads first. Then we'll do it on the board. How many bits does it take to create 192? It takes 2 bits. Okay? Okay. 128. I have to increment. The increment is by 64. We're going to put it on the board in a second, but you can see how you do it in your head. And be like, oh, okay. 64, 128. And if I do 64 again, is 224. Right? Yeah. No, it's that's 224. Is it? Let's see. Let's put it up there because my math is whatever. Let's go here. 64. Then you got 128 and 64. That will be 12, 1, 2, 2, 3, and 6, 9. Oh, it would be what? $192. That can't be right. Oh no, yes, it can be right. 192. Let's say yeah. 64. 1 is 12. Okay, 1, 2 is 3, 3 and 6 is 9. 192. Okay. So we're incrementing by 64 because our magical line is between 64 and 32. Okay. Now you notice that then it started counting from 0. All right. So we could put 0 up there. All right. Let's hit enter. Let's put 0. 0, 64, 128, 192. Right. I just want to make sure I got this right. I'm still debating this right here. 64. Yeah. And then 64. That would be it. 1, 2, 6. That's it. These are only 4 networks you're going to have. All right. So the question is, what is the broadcast address of this particular network? The 128 network. Well, there's many ways you can do this. If our line is right here between the 64 and the 32, if you were to add all the bit values to the right of that, right? The line's right here between 64 and 32. If I were to add all these bit values here, it will come out to 63. And 63 and 128 is 191. But guess what? 1 less 192 is 191. All right? And that's it. That's as far as you got to go. Don't go crazy. Answer the question. All right? Just don't start doing all sorts of things. If they want the broadcast, well, here you go. They got it, 191. So the broadcast address for the 128 network, which is right here, okay? And the way we got that is because we looked at the mask, said, hey, 192. Well, 128 and 64, that's 192. So then we know the line is right here. And when we did our math, it came up 191. So let's see what the answer is. Lo and behold, it is 191. Okay? This method never fails. Now we're doing what's called class full subnetting. What does that mean, class full subnetting? It means that you have the same subnet mask throughout your entire network, which doesn't make sense. All right? Because class full subnetting, that means if the accounting department has only 2 people, why would you use a /24 or even this one? Okay, you have to move the line back and forth, and that's variable length subnet masking, which we will get into. Okay, but here this is class full subnetting. Imagine having 2 routers. You got 2 routers that are interconnected with each other. Are you going to use a /24? Of course not, because you're wasting IP addresses. You're going to use a /30 because a /30 or a CIDR 30. Okay, will allot you for 2 IP addresses. 2. Now I know there's people out there saying, well, hey, Laz, why don't we use just a CIDR 31? We can have 1 IP address and use the IP unnumbered for the others. Yes, you can do that, but as you create and get bigger, it runs into problems with routing protocols. So don't get creative, okay? Stick to the /30 and be done with it. If not, you have to start doing all sorts of craziness, all right, to make it work. So don't do that. All right, just like the secondary IP address that we can put in IPv4, it's never used, okay? So that's one. Let's do another one. Let's do another one so you get the hang of it. Let's erase this right up here. All right, and let's go to the next question. So you don't think it's me that have pre-answered questions. Okay, so it's asking us, which subnet does this particular host belong to? Which network? So 23, you know you're working on the last octet, on the third octet, because you have 8 on plus 8 on plus 17, 18, 19, 20, 21, 22, 23. Hey, look, it's just like the first problem. Where's the line? Keyboard command. 0.1, 2, 3, 4, 5, 6, 7, 8. So there's your line right there. What are you incrementing by? You're incrementing by the number 2. So definitely we're not going to increment by 2 till we get to 200. We know that 2 times 100 is 200. Okay? So what network does this guy falls in? Falls in the 200 network. 200.0. Right? 2 times 100, it's 200. 200.0. Let's write that out. All right, so it's going to be x.x.200.0 and then x.x.200.254. No, not 254. And it's not 200 either. It's 201. Sorry, .254. Because I am adding this bit value, which is 1, to the third octet here, which makes it 201. And then this is not 254. Well, that's the range. This, I was looking for the broadcast. I was looking for the range. Okay? And then when you add these bit values, which equal 255, you add it to the fourth octet, which is this guy right here. All right? It's 255. So does 200.145 falls in here? Sure. You got from .1 to all the way to 201, 254. So that falls in the 200 network. That's the subnetwork it belongs to. Let's click on the answer. There you go. 200.0. Okay? And all I did, I said, okay, let me draw my magical line. Let me see the bit value to the left, what it increments by. It increments by 2. So I said to myself, what number can I multiply, Laz, by 2 that gets me close to 200? Because I'm not going to sit there on a 90-minute test and say 2, 4, 8. No. 2, 4, 6, 8, 10. You're gonna waste time. All right. So there's no, and I know all of you have been taught 2 to the 2 minus 2, 2 to the n minus 2, all that craziness. All right. No, this is the easiest way of doing it. I'm telling you right now, you better listen to me. All right. Yes, it's a threat. No, I'm just kidding. All right, let's do another one. You got to know how to do this. Again, classful subnetting, because you're going to have the same amount of IP addresses within that network. All right, what do we got here? What is the valid host on the subnetwork 192.168.44.224? That's funny. What is the last valid host? Well, ladies and gentlemen, 224 is the last network. So we're talking about the very last network where there's 3 bits on. So let's put that up here. X.x.x 1, 2, 3, line 1, 2, 3, 4, 5. Okay. That means these 5, okay, these 5 are on. I mean, that's what you would add, all right, to get your broadcast address. Okay, so this will equal to 31. Well, what's 31 and 224? It's 255. So what is the last available IP address? Last valid host. It's 254. Let's look at the answer. 254. It always works out that way. Okay? If you have a 128, a 192, a 224, a 240, a 248, a 252, a 254, or a 255, those will be the last networks. Always, 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 always. All right. So this is why when I looked at this, I said, okay, so this is a network. It's the last available network. So all I really got to do is just add these numbers together, which is really one less the increment, which is 31. So I add 31 to that 224, gives me 255. That gives me the broadcast, right? So what's one less the broadcast? 254. There you go. I got my answer. All right. Last one. Last one. Okay. Which subnet host does this IP address with a CIDR 27 belong to? Which subnet? So first of all, look at 127. So let's erase this right here. So I don't want to cause any confusion. All right. So we're in the last octet. How many bits in? Come on. How many bits in? So it's CIDR 27. 3 bits. You're right. 1, 2, 3. Line 1, 2, 3, 4, 5. Is that 5? Yes. Okay, so we're incrementing by what number? If my line is right here, I'm incrementing by 32 on the last octet. Well, I got to get to 150. Okay, well, got no choice there. I can't multiply that high, so let's go ahead and do that. 32, 64, 96, 128, 32, yeah. 160. Right? Well, there you go. You went over 150. You went over 150. So what's 1 less 160? 159. So 150 falls in this particular range right there. So I'm like, all right, I found my line. I saw my increment, which is 32, the bit value to the next to that. And then I went one more just in case, and I found out it was 160, which it goes over that 150. So I said, okay, what's 1 less 160? 159. So I know that 150 falls in between 128 and 159. So the subnet that it belongs to is 128. 128. And let's see if that's true. And it does. Okay. So the reason I'm using this website is so, again, you don't think that I'm just making up numbers and you're like, oh, he already knew the answer to that. No, no, no. This website is awesome because it's not going to explain anything to you. It's just going to throw out questions at you. What I've explained to you here is what you need to be going over and over and over and over again. And if not, hello, Amazon.com, get the book, okay? It's going to break it down for you if you need extra help, okay? But definitely, all right, that's what you look at. I concentrate on that subnet mask. I need to know where that line is at because I need to know what my increment. Once I find out my increment, it's over because I increment to whatever octet I'm in, with the number. Maybe I'll go one after, so I just say, okay, one less, and then that's it. It's over. You should be subnetting within 30 seconds. That way, it will give you more time to answer the other questions. Okay? Because if you answer one question in 10 seconds, hey man, that increases your chances for another one. Because you will run into questions where you're going to be like, and you're going to be thinking. You have to think. It may take you longer than a minute and 30 seconds. So things like OSI model, IP addressing, any type of IP addressing, okay? Basic configurations, silly little things like that, routing protocols, basic routing protocols. Shouldn't waste your time on it. Should be quick. Move on to the real deal, which is the simulations. And then, the second part of it, which they start talking about BGP, DMVPNs, all that good stuff. All right? All right, then. I hope you understood. Here was the breakdown. All right? And what I actually do, you look at the subnet mask. And remember, classful subnetting, what it means is that you have the exact number of IP addresses per network, which is not a reality. Okay? The reality is what? VLSM, variable length subnet masking. And we'll be talking about that soon. See you next. All right, here we go. Class full subnetting, but with a class C address. Now, we did it already, but we're gonna do one example with a class C and then a class B and then a class A, right? Because everybody wants me to do each different one. Not a problem. So the issue we got here, we got an IP address they gave me, right? I'm gonna move this up a little bit, right? They came to me, my boss came to me, he gave me this 192.168.00 CIDR 28. So he goes, hey, Laz, you need to go ahead and assign the networks, the IPs to, give them to your people. They need to go ahead and put in their IPs to their nodes. I'm like, okay, no problem, I got it. So I said 28. I said, well, that's an increment of 16. As you can see here, I did my little formula, my little diagram, and I saw that it was a 16 increment. So I incremented by 16, starting from 0, and it goes all the way to 240. Okay, 240. And it will always work out that way where your subnet mask, okay, your subnet mask will always be the last network. Now, it used to be back in the old days where the network side you would subtract 2 because the older iOSs did not understand the zero network, meaning 0, and did not understand the very last network that included the subnet mask in it. So you would subtract 2. In today's networking environment, the iOSs do understand the zero network. Now, there is a command called IP subnet -0. No need to type it in. If you type it in, it's not going to hurt anything. But the routers do understand. The iOSs do understand that. All right, so it's not a big issue. So you do not need to subtract 2. But again, in your certification test, pay attention to the question. Use the subnet 0. Don't use the subnet 0. So if you use subnet 0, all networks are good to go. If you do not use subnet 0, then you got to take out 0 and you got to take out the very last network. Okay? All right. So they're giving me this. We're using subnet 0. All right. And I got to start assigning. I said, listen, hey, Tony over there, you're going to have the 0 network and your CIDR is 28. Yeah, but I don't remember how to. Okay, no problem. I'll give you your broadcast so you'll know what's in between. So then I go, all right, what's 1 less 16? 1 less 16 is 15. So, that's 12. So that means that 1 less 16 is the broadcast for the 0 network, right? It's a little diagonal line going like this. So what's in between? 1 through 14. Okay, cool. We got that. That's Tony's. Now we go to Susie, right? Susie, she's on the 16 network. Okay. So on the 16 network, again, I'll let her know. I said, okay, you go to 32. 1 less 32 is what? 31. 31 is her broadcast. So let's put it right there. I touched the screen, so I got to put this thing in here back. So 31. So in between 60 and 31, what do you have? 17 through 30. That's her usable range. And then we go to this one here. That's, I don't know, Sally, let's say. And then we have, she's in the 32 network, but she needs her broadcast. Okay, well, what's 1 less 48? Well, that's going to be 47. So 47 becomes the broadcast address of the 32 network, which then you have 33 to 46. And you can verify this by saying, all right, if I were to add these bit values right here, 15 and 0 is what? 15. 15 and 16 is 31. 15 and 32 is 47. And you can keep going all the way down. Or you can simply say 1 less a network. 1 less 64 is 63. And that's going to be 48's broadcast, and so forth, and so forth, and so forth. So that makes it that simple. So he knows now that he's got from 49 to 62. So that's a class C, or within a class C using a CIDR 28 mask. That's as simple as it gets, as easy as it gets. Again, the subnet mask is the key. Drawing that line, knowing your increment, and once you increment all the way down, you got it made in the shade. All right? I'll see you in the next one. All right, everyone, welcome back. We just finished doing a class C, right? That was very simple, all right? But we're going to do this a little bit different. We're going to do a class B now with the same methodology, but we're going to go inside the lab. Why? Because I keep getting in your way. I keep bending over, backspacing, all these different things, moving around. I don't want to be in your way. I want you to have a clear look at everything. Basically, it's going to be the 172.31, 121.86 with a CIDR 19. And we're going to go ahead and break this down. And you can see I already have, but I'll explain it once we get inside the lab, okay? Same concept. Remember that. Same concept. I'll see you inside the lab. All right, let's get inside the lab. Now, like I said before, we're doing this a little bit slightly different. We're doing a desktop recording mode just for the fact that I won't get in your way, okay? We just finished doing a Class A subnetting. Now we're going to do a Class B subnetting. The only difference is that, well, obviously we're using a Class B address, but as well, we're now working within the third octet, So how does the question go? The following host address belongs to what subnet? So they've given you this particular address right here, okay? So your focus again is this CIDR 19. So you have 8 and 8, that's 16, 17, 18, 19. You draw your line. That line already tells you that you're incrementing by 32. Now remember, our focus is here. So if we're incrementing by 32, and since we're using the 0 network, so let's go. So we go 0, 32, 64, 96, 128. Well, 128 goes over 121. So what is 1 less 128? Now, obviously, this is 96.0 because that's the third and the fourth octet is completely off. And this would be 128.0, but I'm not going to do it for the rest. All right, they're the same thing. Now, let's get our broadcast. And how do we do that? Well, we're going to add these bit values in our third octet, which is 31, which is 1 less your increment, right? Or your network increment. So 31 and 196, well, that's 127. 127 dot, and then if you add these bit values, that will be 255. So this would be your broadcast. Oops, too many fives. So you have 96.0 as your network ID and 127.255 as your broadcast ID. That means that 121.86 does indeed falls in this range. So what would be the answer? Well, the host address belongs to the 96.0 subnet. Yes, the 172.31. That 96.0 subnet. And again, the only thing we did, this is going to become redundant, is we looked where to draw the line based on the mask that was given. So this is how you would do a Class B, using to focus that, hey, we're working on third octet, so we can't forget that we have a fourth octet, so we can add the bit values to the proper octet and then get our broadcast ID. And that's it. I'll see everybody outside the lab. All right, that wasn't so bad, now was it? Same concepts like I said before. All we did, we found where we draw our line based on that particular subnet mask. We saw that we incremented by 32, and we did, which gave us the 96.0 subnet. So again, it's just following, looking at our subnet mask. Not a big deal, all right? I'll see you in the next one. All right, welcome back, everyone. We're going to be doing now Class A. Nobody can say that. I've never done C, B, or A now. So this is going to do Class A address. We have a CIDR 13 that we're working with. So we're going to, again, go inside our lab so you have a full view of the whole thing. And I will explain to you as we go. But again, same methodology. I'll see you inside. All right, here we are again. Now this time we're doing a Class A, and let me get this numbers up here out of the way. All right, so we're doing a Class A address. Ignore this, okay? So we're doing a Class A subnetting. Again, we put our bit values, right? And they're asking pretty much the same question. The following host address belongs to what subnet? Here we go again. What do I pay attention to? I pay attention to the CIDR notation, the subnet mask, 13. So I go 8, 9, 10, 11, 12, 13. So this is where I draw my line. Now I do the last 8 bits, which are off, and then 2 octets, right? Because I am now on the second octet. This is the interesting octet. So the last 2 octets, the third and the fourth, are off. Okay, so what do we increment by? Well, 1, 2, 4, 8. We increment by 8. Well, what number can you think of that you can multiply by 8? Because I don't want to increment by 8, right? Let's not do that. It's just 8, 16, and 24. I don't want to do that. So 8 times 10 is 80. 8 times 11 is 88. 8 times 12 is 96. Look at that. Okay. So 8 times 10 is 80. Let's start from there. So remember, and x dot, so we know where we're at. X 80.0.0, right? X dot 88, right? .0.0, and then x dot, oops, let me enter one more time to give you space. X dot 96.0.0. Okay, so we got these increments. I'm going to lower this page a little bit. All right, so now our focus is this 91, our second octet. Okay, we're incrementing here on the second by 8. So where is this 91 you think will fall? Well, it can't fall in the 96 because that's much bigger than 91. So it has to fall in here. Okay, well, let's find the broadcast for that. Well, we know it's x dot something. X, what do we add here? What are these 3-bit values? The 4, the 2, and the 1. Well, that's 7. Well, what's 7 and 88? 7 plus 88. Well, that's 95. Okay. So we know that if we add all these bit values right here, that's 255. Well, we got 255 right here in the third octet. And the same thing goes for the fourth octet, 255. So there is your broadcast address for this particular subnet. So what is the range of addresses that we have? Well, we have x dot 88.0.1, oops, through x dot 95.255.254. And let's bring this broadcast ID a little bit closer. So we know that 91, 103, 245 must fall in this range because here you look at the second octet, 91, it goes all the way up to 95. 103, it goes to 255. 244 goes up to 254. All right, so we have found the subnet that this particular address falls in. It falls on the 88.0.0 subnet. Okay, again, we did the same process. The only difference is that now our focus is on the second octet, but we just can't forget about the third. That's why you see me, I added the appropriate bit values to the right octet, right? And then the third octet, I added it to the third octet, and then the fourth octet to the fourth octet, and so forth. And that's how you do classful subnetting. It's redundant for any IP addressing question. This is what you do. Focus on your subnet mask. I'll see you outside the lab. All right, everyone. That wasn't difficult, but you do got to pay attention. You saw that we were working in the second octet, okay? In the second octet, as you can see right here. So you can't forget about the third and the fourth, all right? But it's the same concept over and over and over again, all right? So now you've done a C, a B, and an A. And you saw that there were different masks, and you saw it's the same thing over and over again, just on different octets, okay? So that's it. I will see you in the next. All right, everyone, welcome to the summary of this particular section, which is on classful subnetting. All right, we went ahead and we did a CBNA. We took each one of these addresses, even though they were private addresses, doesn't matter if they're private or public, it still remains the same, right? We take a look at our mask, we draw our line, we see how we increment to the number in whatever given octet that we're working in, all right? And then we add the bit values on the right according to what octet they're in to get our broadcast, and then whatever's in between. That is classful subnetting. What does it mean? It means that you have the same number of IP addresses in every single segment or network of your enterprise company, okay, of your company. So that's what classful subnetting is. All the routing protocols support it, no big deal, but I'm just letting you know that it is a waste of IP addresses because that's not the reality. Not all of them are going to have the same amount of IP addresses in each particular segment. All right, that's it for this section. I'll see you in the next one.